Welcome to AI Simplified. It's all about artificial intelligence.
Hey guys, welcome to my channel. Today we are going to move forward in our project fraud detection with AI. The first part was to finding a data set, which we have already done, and now the part second, pre-processing the data set. We would do it in this video. So let's start. In here you can see I have, this is from the last video. I will just run all these ones. Yes, so in this part we can have the pre-processing, processing. So the first thing we would like to see is how our data set looks. So I would explore the train data frame. As you can see from here that we have some dimensions from the last videos, and we would look at them in a few minutes. It's just running. Till then, let's start. So first I would like to see what is like inside this data frame. So I can just do train data frame describe, and also I would like to see how much, like what is the content of the data frame. So what I can do is use data frame dot head and like this. So it will print the top 100 rows of the data frame. As you know from the last video, we won't be using the test data frame because it's for the prediction part and we don't have the labels actually, so we cannot get an accuracy for it. And it's about to complete, so I'm just waiting for it to complete so we can move ahead with this. Yeah, so it's done now, and I would run this train data frame describe. So here I have given the name, okay, train trans. So let's say train trans dot describe, and you will get a sort of summary of about the data frame. And you can see that in down that it's like calculating various things like the count, mean, standard deviation, quartiles, and the maximum value for all these columns. And we can also show the top 100 rows of the data frame with this train trans dot head. And you can see that there is this label is fraud, which we will be using for predicting whether it's fraud or not. So let's deep dive into pre-processing part. So the first thing we want to do is remove columns with any values because they won't be of much use to us. So first we will do train data frame, and then we have train trans data frame, and then delete. But before that we can all, so we have, if you remember that we have one more data frame, train identity head 100. So we will have another data frame with the transaction ID and then the identity of the person. You can think it is like this way. So I would first like to merge these two data frames together so we don't need to do pre-processing two times. And so first I create a merging both data frames. So how do we merge these two data frames? It's pretty simple. All you have to do is to use the Pandas Merge command to merge these. So let's start. So we will say train data frame, which is pd.merge which to train transaction and train identity on what you want to merge this. That would be the transaction ID and how you want to merge it. So I would like to merge it like inner, only the rows which are common in both these tables will be shown. And then I also want to print the dimension of this. So you can see there are 394 columns in the train transactions and 41 columns in the train identity. And when I print it now, the train data frame, then we can see the total is 434. So everything is combined. Now let's take down this two column. The first is to remove all the NA values. For this I would be using drop NA function from of the data frame. You can see drop NA, and what we have to select the axis. So axis for this is 1, that is only the columns, and how is all. And once we have this, we will again print the shape of this. Okay, and now there are almost 21 columns that have been deleted from our data frame. The second thing we would like to do is to take the label out, which is train label, and then we can do train data frame, and we remove this label and copy it. We copy it to a different train label, and then we drop it from our main data frame. So we have like separately our data frame and the labels. You can also keep it into the same data frame, but it's advised to do it in separate, two different data frames. And then I just run it, and then you can just see again with this command that you can same with this command that there should be 412 columns, and we have another new train label, and you can do just the length of this. So it's exactly same, but just only one rows, and if you print this train label, you can see it should be just 01001 values. Okay, so now we have a data frame without the labels, and now we would like to pre-process it more. So what we can do more? The thing that we would like to do more is to use so there will be missing values in this data frame. So we want to fill this missing values, and for this we are going to create transformers which will do this job easily for us. That would be from sklearn.impute for the imputers, that is a simple imputer. Then for the categorical, we also need categorical, that is from sklearn.preprocessing, and we import the one hot encoding. So whatever is the categorical variables we have, we will just do them one hot encoding, and then we also create a pipeline so we don't have to do it again and again. And here we have this pipeline, and we also need column transformation. sklearn.compose, and we do import column transformer. We will also use sklearn.preprocessing and standard scaler. We have all the libraries that we need. Let's create a preprocessing for numerical and categorical data. if you don't know what is the categorical data, you can I will be posting videos soon in the future about it. And for now you can understand it this way, that you have features which are independent, like red, blue, green. These are colors which are independent of them. You cannot say which one color is other than better than the other one or something like that. So we want to divide it into different columns and give them a value of 1 and 0. So we want just if it's red we give it 1, otherwise 0. So we will have now 3 columns, one column divided into 3 columns, and then we will have a imputer here like this. Inside this we will have one imputer which is a simple imputer, and for this we will use a strategy is equals to constant, right? And same for this. Again, for the categorical we can just copy this, paste this here. Categorical, we call it the categorical transformer, and we have same here as well. Now we have to create a preprocessor which will like we will say, okay, it's a column transformer, and we want to have the transformations for both numerical and like this numerical transformer, where we have this, and for the numerical columns which we will just define. Right, and one more we need is for categorical. That would be categorical transformer with categorical columns, and in the last just close the bracket and it's done. Then we want to do is to now we divide our data set into train and test. Let's run it. It should work. And then yes, so we also need the numerical columns and the categorical columns. For this we will just move it like a little bit up, and so we can select categorical columns and numerical columns both like this. Categorical columns are the name, columns name for column name in train data frame dot columns. If train data frame, the name of the column dot the type in, and what can be the type of the for it should be object, right? And similarly for this we can have the same code like this, but instead of d type in, it should be in a list of what can be the possible integer 8, and then we have integer 16, integer 32, and integer 64. and then we can also add the float values, which would be the float 8, and then float 16, and float 32, and float 64. We are taking everything, so we don't have to check the data set for these values whether it's there or like what is the value. So if you just run it, and my bad, yes, and if you see categorical columns, so you have everything which is like category, and then we have the numerical columns, the name of all of these columns, and what we are gonna do now is just pass these through this, so we will have a transformed data set. Now for this we are gonna, so we want to train these transformers on our test set, like the train set, not on the test set. We will use this learning only to do is to implement this transform on our test set and learn it on the train set. So we are going to first divide it into two tests, because the test set we have now doesn't have any labels. So we did xtrain, let's say xtrain, xstack, test, ytrain, and ytest. Once you have this, you just do the train test split, and you have to define which one you want to do. I want to divide train data frame and train label with test size. Let's say I want to do the test size as 80-20 ratio, so I will say test size to be 0.2. And then in the xtrain, I want to processor that we have defined dot fit transform on this xtrain, and x value is equals to preprocessor dot transform dot x value. And so this is our test set, and then you can have just run it. Just a preprocessor, yes, and then it should run. Okay, so we have to write constant here, and here constant too. Once we run it, we can see that the whole our data set is done. And if I print x train dot head with 100, so it's in a numpy array right now. The only thing we need to do is like, so you can see it's divided like this from the data set that we have earlier. You can see from here it's 11452, this value 144,000, and now it's 115,000. So we have xtrain, and then we can also have the look at the xtest. Alright, so but if you remember from earlier here, that from the last video, that when we see the count, there was like a really huge difference in between both of these labels. The true positive, that label is 1, the fraud cases and non-fraud cases. So the data set is very skewed, and we want to also consider this. So for this, we will be there are various strategies to come over this, that is oversampling, undersampling. When you increase the fraud cases, that is oversampling, and undersampling is when you cut down the cases which are non-fraud. So we would be using here undersampling, or we can just use a both of these combinations. So let's see, from mblearn.you import oversampling and undersampling, and from imblearn we take the pipeline and import the pipeline. And oversampling, usually it happens with all the fraud data sets that they are very skewed, and you should always do this. So the model is not biased, because if 100 cases 99 are not fraud, the model will learn to say no to every case, and then we will also have a 99% accuracy. And oversampler, then we use sampling strategy equal to 0.1. So we want to oversample the cases by 0.1, and then we want to undersample, that means reduce the cases by 0.5. And once we have this, we can create a steps where you have O for oversampling, and then another one for undersampling, that we call as U for undersampling. Once we have these, we can create a pipeline which should be steps equals to steps, and then we can just use X train and Y train both, because we are doing on both, and then we can just pipeline dot fit resample and pass these values. So if you want to understand some function in Google Colab, you can just hover it like this and you can see about the function. And if I just run it, then we can see that we should get, now if you see xtrain dot shape, so from this 115,000 we have only 31,000 cases, and if we use this again, the same code, to see how much is the distribution, we have this. So if I run it now, it won't work. So I have to change it here first to ytrain, but ytrain is a numpy array, so I have to first import numpy as np, and then from np.unique I can just select ytrain and then return counts, yes, as true. So it will return me the values and the counts, since I'm not interested into the first part, so I can just do this way. And then we have the plot bar with 0, and then you can just print it. So now you say the dataset which is very much skewed is just x y of the train. Now you can see the data set, which is very skewed, is changed, but if you go for the test data set, then it's still the difference is so it looks like a real problem, but when you go for the train part, the difference has been pretty much reduced between these two, so that we can have a better prediction on the model. Thank you guys.